Have you ever wondered if you could leap forward to see the future, or step back to relive the past? The allure of time travel, a concept that has intrigued and beguiled the human mind for centuries, permeating our stories, our dreams, and our deepest curiosities. Time travel is not just a modern fascination. Oh no, its roots reach far back into the annals of history, woven into the tapestry of our collective cultural memory. From ancient Hindu scriptures that speak of divine beings traversing vast stretches of time, to Irish folklore filled with tales of heroes embarking on epic journeys only to return and find centuries have passed in their absence. Then we have the countless works of fiction that have taken the concept of time travel and run wild with it. H.G. Wells's The Time Machine, a literary classic, introduced us to a world where humanity could manipulate the fourth dimension at will. And who could forget the wildly popular Back to the Future series, which brought time travel into the mainstream consciousness, causing us to ponder the possibilities and consequences of meddling with time. These stories, while rich and entertaining, have also served a profound purpose. They've sparked our imagination, ignited our curiosity, and propelled us to push the boundaries of what we perceive as possible. They've prompted us to question the nature of time itself and our place within its relentless flow. But behind the captivating tales and mythologies, there lies a world of scientific exploration. Theoretical physicists and cosmologists have been wrestling with the concept of time travel, trying to decipher its mysteries through the lens of science. Yes, the theories are complex, and yes, they often sound like something straight out of a science fiction novel. But that's the beauty of it, isn't it? As we delve into the science of time travel, the line between fact and fiction becomes beautifully blurred. As intriguing as these stories are, they're not quite the scientific theories of time travel we're exploring today. So buckle up as we dive into the fascinating world of time manipulation, where the future could be the past, and the past could be the future. Let's take a leap of faith into the unknown, shall we? The concept of time travel took a scientific turn with the advent of Einstein's special theory of relativity. Before Einstein, time was considered absolute and universal, marching on at a steady pace regardless of where you were or how fast you were moving. But Einstein's revolutionary theory in 1905 turned this concept on its head. Imagine space and time as two separate entities. Now fuse them together into a single four-dimensional fabric known as space-time. This is the stage on which all events in the universe play out. According to Einstein, this stage isn't flat and unchanging, but curved and warped by the mass and energy of the universe's actors. This is where the magic happens. Picture a bowling ball sitting on a trampoline. The ball creates a dip, a curve in the fabric. Now, if we roll a marble across the trampoline, it will naturally follow the curve created by the bowling ball. Similarly, planets and stars warp space-time, and this curvature guides the paths of other celestial bodies. But Einstein's theory didn't just redefine gravity, it also introduced a startling concept: time dilation. The theory posits that time can speed up or slow down depending on how fast you're moving or how deep you are in a gravitational field. The closer you are to a massive object or the faster you move, the slower time passes for you compared to someone who's stationary or far away from the mass. This relative nature of time, this time dilation, is the first hint at the possibility of time travel. This breakthrough sparked a flurry of scientific exploration. It set the stage for a century of mind-bending theories and discoveries, from wormholes to quantum mechanics, each pushing the boundaries of our understanding of time. Yet, the theory of relativity was just the beginning of our journey through time. As we delve deeper into the rabbit hole of time travel, we'll encounter theories and paradoxes that will challenge our very understanding of reality. So buckle up, because the journey is about to get even more intriguing. Enter wormholes, the cosmic shortcuts that could, theoretically, make time travel possible. These fascinating phenomena were first brought to light by physicist John Archibald Wheeler in the year 1957. But what exactly are wormholes? To put it simply, imagine the universe as a sheet of paper. Now, if you were to mark 2 points on this sheet and then fold it, bringing the 2 points together, you'd have a basic idea of what a wormhole is. Wormholes, in essence, are tunnels with 2 ends each at separate points in space-time. Think of them as cosmic shortcuts, a hidden passage through the universe's spatial dimensions, potentially connecting not just 2 different places, but 2 different times. This is where the concept gets intriguing. If wormholes could be harnessed, they might offer a route for time travel, a way to dart back and forth through the ages. However, it's important to remember that just like time travel, wormholes are purely theoretical at this point. Despite this, they've stirred up a great deal of interest in the scientific community. The mathematics of Einstein's theory of general relativity, which describes the fabric of space and time, allows for the existence of these cosmic shortcuts. But as of now, we have no empirical evidence that they exist. Moreover, even if they do exist, there's the question of stability. Theoretical physics suggests that wormholes would be highly unstable and would collapse quickly. But some scientists hypothesize that a form of exotic matter with negative energy density could be used to keep a wormhole open. As fascinating as wormholes are, they remain a theoretical concept. But that didn't stop us from imagining more possibilities. After all, the pursuit of knowledge and the desire to understand the universe is what drives scientific innovation. And who knows, perhaps one day we'll uncover the truth about these cosmic shortcuts, and the face of science as we know it will change forever. From cosmic shortcuts to parallel universes, the realm of quantum mechanics opened up a whole new world for time travel theories. Quantum mechanics, the branch of physics dealing with the tiniest particles in the universe, has given us the many worlds interpretation. This theory, proposed by Hugh Everett in 1957, paints a picture so vast and complex, it's enough to make your head spin. Imagine, if you will, a cosmic tree of infinite branches. Each branch represents a different universe, each one branching off from every other, every single moment. These are not just any universes, mind you. These are parallel universes existing simultaneously, each one a mirror of our own, but with one crucial difference: a different outcome to a particular event. Think of it like this: every time a quantum event occurs, say a particle spins this way instead of that, the universe splits. One universe follows the path where the particle spun this way, another where it spun that way. This process repeats for every quantum event, creating an unimaginably vast multiverse of parallel universes. It's a concept that's as fascinating as it is mind-boggling. It suggests that there are infinite versions of you, living out every possible life you could ever lead. In one universe, you might be a famous actor. In another, a world-renowned scientist. In yet another, perhaps a humble baker in a quiet town. The possibilities are as limitless as the stars in the night sky. But what does this have to do with time travel, you might ask? Well, if one can find a way to traverse these parallel universes, one could potentially visit an alternate past or future. It's a wild thought, isn't it? This interpretation of quantum mechanics is far from universally accepted, of course. The concept of a multiverse is still very much a topic of heated debate among physicists. But isn't it fun to ponder the possibilities? In this multiverse, every choice you make creates a new universe. Imagine the possibilities. But what about the paradoxes? What happens if you go back in time and prevent your own birth? These are questions that often come up when we talk about time travel. And they lead us into the realm of time travel paradoxes, a territory where logic and causality seem to play tricks on us. Let's start with the grandfather paradox, a classic thought experiment that involves traveling back in time and preventing your grandparents from meeting, thereby preventing your own birth. If you were never born, then how could you have traveled back in time in the first place? This creates a loop in causality, a catch-22 situation that seems to defy logic. Then we have the bootstrap paradox, a temporal anomaly named after the phrase, pulling yourself up by your bootstraps. It refers to a situation where an object or piece of information sent back in time becomes trapped within an infinite cause-effect loop, in which the item no longer has a discernible point of origin, and is said to be uncaused or self-created. For example, imagine finding a mysterious book with no author listed. You read it, love it, and decide to use a time machine to give the book to your younger self. Your younger self then reads it and later gives it to their younger self, and so on. So, who wrote the book? It seems to have no beginning or end, existing in a state of perpetual self-creation. These paradoxes present real challenges to the concept of time travel. They force us to question our understanding of cause and effect, and whether time is linear or not. Some theorists suggest that these paradoxes could be resolved by the many worlds interpretation of quantum mechanics, where each decision creates a new parallel universe. But that is a topic for another day. For now, Let's just say that time travel is not as straightforward as hopping into a DeLorean and hitting 88 miles per hour. These paradoxes present real brain twisters, challenging our understanding of time and causality. Fast forward to the 21st century, where time travel theories are still evolving. We've journeyed through wormholes, debated quantum mechanics, and tangled with time travel paradoxes. Now, we're breaking new ground with some of the latest developments in time travel theories. One such development is the concept of time crystals. These are a new phase of matter proposed by Nobel laureate Frank Wilczek, and they're shaking up our understanding of physics. Time crystals are unique because they move in a pattern that repeats in time, not just in space. This could potentially provide a way to represent time within the quantum world, a feat that has eluded scientists for decades. Another intriguing theory is time travel using quantum teleportation. This idea hinges on the principle of quantum entanglement, which Albert Einstein famously called spooky action at a distance. In the quantum realm, entangled particles are deeply linked, and the state of one can instantly affect the state of the other, no matter how far apart they are. Scientists are exploring how this principle could be applied to teleport information through time. There's also the concept of closed time-like curves, a solution to Einstein's field equations in general relativity. These curves could theoretically allow an object to return to its own past. However, this remains purely theoretical for now, as creating such curves would require conditions not currently achievable. As we delve deeper into the quantum world and continue to push the boundaries of our understanding, these theories may evolve, and new ones may emerge. The journey is far from over. The realm of time travel remains as tantalizing and enigmatic as ever, a testament to the boundless curiosity and innovation of the human mind. As we continue to unravel the mysteries of the universe, who knows what new theories will emerge in the future? So, what is the bizarre truth behind these time travel theories? You see, the riddle of time travel is as tantalizing as it is elusive. As we've journeyed together through wormholes, quantum mechanics, and paradoxes, we've seen that time travel is not just a figment of science fiction, but a concept deeply rooted in the realms of theoretical physics. From the birth of time travel theories, we've seen how they've evolved, with each theory more intriguing than the last. Wormholes, for instance, these hypothetical shortcuts through the fabric of space-time, could potentially allow us to journey both forwards and backwards in time. Or the many worlds interpretation, a quantum mechanics theory that posits the existence of infinite universes, each representing a different outcome of every decision we make. Then we've grappled with the paradoxes that time travel theories present. The grandfather paradox, the bootstrap paradox, and more, each one a mind-bending challenge to our understanding of cause and effect. But here's the kicker. Despite all these fascinating theories and concepts, the harsh truth is that time travel remains largely theoretical and unproven. There's no definitive evidence to suggest that it's possible to journey through time, at least not in the way we often imagine. The scientific community continues to debate the possibilities, with ongoing research exploring the outer reaches of our understanding. Yet this doesn't diminish the allure of time travel. If anything, the uncertainty, the unknown, it only adds to the intrigue. It fuels our fascination, pushing us to delve deeper, to question more, to explore the farthest frontiers of our knowledge. Whether time travel will ever be possible remains a question for the future. Until then, we can only imagine the possibilities. From mythological tales to quantum teleportation, the journey through time travel theories is as fascinating as it is complex. We've traversed the labyrinth of wormholes, quantum mechanics, and paradoxes, to the latest in time travel theories and the bizarre truths behind them. And yet, we've merely scratched the surface of this fascinating subject. If this journey sparked your curiosity and set your thoughts ablaze, why not share your reflections below? We'd love to hear your theories, questions, and insights. And if you're hungry for more mind-bending content, don't forget to hit that subscribe button and turn on notifications. But our journey doesn't end here. We're about to plunge into another realm of mystery and intrigue. From the dizzying heights of space-time, we're diving deep into the hidden secrets of the ocean depths. Stay curious, and until then, keep exploring the mysteries of our universe.